Hello everyone. In this video, we'll be discussing about the measures of shape. So let us start. Measures of shape are the parameters which tells us about the shape or the variation in the shape of a distribution, specifically the normal distribution. The different measures of shape that we will be dealing with are skewness and kurtosis. Let us see what do we mean by skewness. Skewness is a measure of asymmetry in the normal distribution. We know that a normal distribution graph has zero skewness, or we can say that a normal distribution graph is symmetric about the center point. But if the normal distribution graph is asymmetric, in that case, we call our distribution to be skewed. This is the formula to calculate the value for skewness. Here, S represents the standard deviation, X bar represents the mean, and N is the number of observations in the sample. If we are considering a population data, in that case, we can replace this N minus 1 by N. There can be two types of skewness present in a normal distribution, which are positive skewness or right skewed, and the negative skewness or the left skewed. Now let us see how a right skewed or a positive skewed distribution looks like. Let us take an example of the distribution of wealth in a society. On an average, we know that most of the people in the society will have a wealth distributed in this region. That is, there will be not much variation in their wealth. But for few people like Anil Ambani, Gautam Adani or Elon Musk, because of the people like them, we get a narrow tail-like distribution because such people are very few, and hence my distribution gets skewed. The region where my distribution gets tapered on one end, we call this region as the tail. So this is the tail of distribution. For a right skewed distribution, we can clearly see that the tail is present on the right hand side of the mean. For any distribution, we know that the mode represents the point with highest frequency or the peak of the graph. So the mode will represent the peak. Median represents the center point. We know that because of the presence of outliers, I have a wide range of data. Because of this, the center point will shift a bit on the right, and hence I'll get the median, which is greater than mode. The value of mean is again affected by outliers, and hence they'll get shifted more on right. So for right skewed distribution, mean is greater than median is greater than mode. As we have seen, in this case, the outliers will be present on right side of the curve. The common example of such distributions are the distribution of wealth and the distribution of marks scored in a difficult exam. For example, if an exam was difficult, most of the students will score marks in the lower range, while very few students will get marks in the higher range, and hence we get a right skewed data. Let us see the left skewed or negatively skewed distribution. Unlike right skewed distribution, for negatively skewed distribution, the tail is present on the negative direction, or we can say that the tail is present on the left side of the mean. For left skewed, mean is smaller than median is smaller than mode, and the outliers will be present on the left side of the curve because the tail is on the left. The common example of left skewed distribution are human lifespan. As we know that most of the humans will have a lifespan in the range of 40 to 60, but there will be very few people who die at an early age. So because of this, we get a left skewed distribution. Another example is marks scored by students in an easy exam. In an easy exam, most of the students will get marks in the higher range, while very few students will get marks which is low. Hence, we get a left skewed distribution. Moving ahead to kurtosis. Kurtosis measures whether your dataset is heavy-tailed or lightly-tailed compared to a normal distribution. Kurtosis simply tells us if the shape of the curve is normal, flat or peaked. There are three types of kurtosis: mesokurtic, platykurtic and leptokurtic. Let us see each of them in detail. Starting with leptokurtic. By lepto, we mean skinny or thin. So in a leptokurtic distribution, most of the data points are concentrated towards the mean and we get a steep distribution. Leptokurtic distributions has a longer tail than a normal distribution and hence it will have more number of outliers. For leptokurtic distributions, the value of kurtosis is greater than 3. Then we have the mesokurtic distributions. Mesokurtic distribution are the distributions which are similar to normal distribution. The value of kurtosis for such types of distribution is 3. Then we have the platykurtic distributions. Platykurtic distributions represent a flat curve which has a broad looking peak and have a shorter tail. Since we have a shorter tail, we have very less number of outliers. So that was all about measures of shape. In this, we saw about skewness. We saw the difference between a right skewed and a left skewed data. Then we studied about kurtosis and the types of kurtosis. If you liked the video, then don't forget to hit the like button and subscribe the channel. Thank you.